research and development and decision-making tools for stakeholders. Dr. Kneifel oversees the development of software tools that calculate sustainability performance of individual building products. It's called Buildings for Economics and Economic Sustainability, BEES, and also Blue Buildings, which is building industry reporting designed for sustainability. So we're going to hear about the birds and the bees from Josh.
Well, thanks for the introduction. Thank you all for coming. Hopefully, at least one of the topics I talk about today you'll find of interest. So just a quick background on me. PhD in economics, so that's what my background is in. But since I've been in this about 8 years ago, I really picked up a lot of engineering with cold home and energy simulation work, environmental science, industrial ecology, looking at environmental impacts. And so what I'll talk about today will cover a range of topic areas. And some of them I know a little bit better than others. Obviously, the ones that I'm the project lead for, I know in great detail. The others I probably know just enough to be dangerous. So if you have questions, you can ask. If I can't answer them, I can introduce you to the person that can answer them. So for those of you that aren't familiar with this, it actually started as the National Bureau of Standards. One of the key drivers was an issue with fire hydrants, or it used to be private companies that had their own firefighting companies, and they all had different fire hydrants with different connections. And so what ended up happening is fires in a major city, and each of the fighting companies couldn't help each other out because they could only connect to their particular fire hydrants. So that led to the desire to standardize some of those types of things. And that's kind of what led to the National Bureau of Standards being created. I believe it was late 80s, early 90s when they shifted to NIST, the National Institute of Standards and Technology, to kind of broaden the scope. And really what it's focused on is improving industrial competitiveness for U.S. industry, really focused on measurement science, being able to standardize processes and trying to increase technology adoption, both in terms of the economic impacts for the U.S., but also for the quality of life for the U.S. citizens. And different labs at NIST, ranging from nanotechnology, neutron research, IT, but I'll be focused on the lab that I'm in, which is the engineering laboratory. No, it's okay. I'm trying to get that. So there's 3 overarching goals within our lab. One is really focused on energy efficiency and sustainability, really across kind of 3 major thrusts of manufacturing, materials, and infrastructure. There's also smart manufacturing, construction, and cyber physical systems. So this is really looking at automation and technology, and then disaster resilience in terms of building infrastructure and communities. Those are really kind of the 3 main goals of the lab. And for the areas of expertise in the lab really fit into those goals, ranging anywhere from fire-related research to structural integrity, looking at the World Trade Center, and this actually did the report that explained how the structural failure occurred, looking at building and renewable energy, indoor environment, and so forth, systems integration and automation, sustainability and service life prediction for products, and along with having issues with the webinar.
They can hear you, they can't see it.
Okay.
Let's just keep going.
All right.
No.
There we go. So within these areas of expertise, I think some of the best examples of explaining it is to look at some of the actual the lab space and the equipment that we have at NIST. So if you want to start the bottom right, it's actually referred to as the sphere. And what that can do is actually replicate the heat and impact of the sun multiple times over. So it's a way to drastically increase the deterioration of products. And so it's a way to try to make predictions on service life of products, but doing it at a much faster rate. So as opposed to having to wait 30 years with the research to determine whether or not a product actually lasts 30 years, you can do it at an accelerated rate. On the top right, this is just a piece of the obstacle course that was developed for robotics. So the all-terrain robots that you can go and try to find like the roadside bombs and so forth, making sure that they can actually handle the uneven terrain that you would see, making sure that the robots can actually go through. And there's one where I think they have to cut through a wall and so forth. So there's a range of different types of obstacles that they have to deal with. The bottom left here is the net zero energy residential test facility. So it's a 2-story house, has a look and feel of a house in that neighborhood. So if you dropped it in the neighborhood across the street from NIST, it wouldn't look weird, as opposed to a lot of the low energy homes that you see. They're very contemporary. Some people do not prefer the look of those. So it's 2-story colonial, but it does in fact produce more electricity than it consumes for a given year. So we've gone through a couple of years of demonstration to show that, and now they're starting to do a lot of unique tests of running different types of equipment and so forth. So they're shifting towards that test facility phase as opposed to just demonstration. Up here in the top left is the extension to the large fire lab. So the original large fire lab is here on the right-hand side there. You can actually see how much taller it is. So you can actually build and burn down multi-story buildings in there if you wanted to. Also, it has a strong wall and a strong floor, so you can actually put the loads onto the building. So one of the issues with the World Trade Center was that you had the combination of all that load on the building with the heat, and that combination actually led to the buckling and the falling down of the buildings. So they can actually do that. They've started some tests now to just basically test to see to test some single beams to make sure that everything's functioning correctly. And at a much smaller scale, here's a piece of equipment called the NIST Dragon. What this has done has been developed to try to replicate wildfire, creating embers that go flying in through the air. So a wildfire can actually send those embers miles. So you could actually be fighting the fire at the main line, and then these embers can go flying over into the houses. So that's another issue with regards to trying to reduce fire related impacts. So there's kind of unique equipment, unique laboratory space that NIST has. And then with regards to the Applied Economics Office, we're obviously not working with or in those facilities on a day-to-day basis. We're much more sitting in front of a computer, analyzing data, and so forth. But we're involved with basically all the different divisions within the laboratory. We have a wide range of research areas that we work in, and basically all those I'll touch on the different projects that we're currently working on. And we have a wide range of skill sets as well. So depending on what we need to do in terms of the analysis, we have that particular skill set available. We're mostly economists, but we do have 2 engineers within our office. And we also have an IT specialist to help with the software development. And we also actually have, even though he's an economist, he actually also has a law degree. So we actually have some background in that area as well. So now I'll go through some of the different projects that we have going on. And at the end, maybe I'll mention a couple that are kind of in the works at this point. So my project, my main project that I lead, is Metrics and Tools for Sustainable Buildings. What this is really trying to do is trying to quantify sustainability, trying to actually use scientific methods and developing metrics that can actually be compared. The 2 main metrics that we use, life cycle costing and life cycle impact assessment. So I'm assuming most of you are familiar with the life cycle cost methodology.
when it comes to life cycle impact assessment, really all that's doing is it's accounting for the environmental flows associated with what goes into a product and the use of the product, or eventually whole buildings, and quantifying that over its entire life cycle. So it's a similar methodology to life cycle costing. You're just looking at the environmental impacts. A couple other metrics that we are starting to work in are related to the indoor environmental quality, thermal comfort, and indoor air quality, which we're using CO2 levels as a proxy for good indoor air quality. And our target audience is really broad. Obviously, standards and codes organizations, government agencies. We do a lot of work with government agencies. Had a lot of interactions with different trade groups in the private sector, and also academia has interest in what we're doing, and the general public at large. Because when we develop our tools, we're trying to develop them in a way that you don't have to have a lot of background in the area to use them. So we're trying to target a wide group of stakeholders. And we do publish a lot related to this, but I'm actually going to focus on software tools that we've developed. There's three in particular that I'll talk about. The first is BEES, Building for Environmental and Economic Sustainability. And what this is allowing you to do is to compare similar products, so different types of insulation, different types of flooring, and compare those across the economics and the environmental impacts. This is really targeting people that are designing buildings and trying to select products, or for say sustainable acquisitions requirements, which at least the federal government have drastically increased as of late. We'll see how that may change over the next 4 years, but at this point it's a pretty with the executive orders, they have pretty significant requirements that they have to meet. So this is the basic framework. I'm not going to go into the details because you'll probably get bored. If you want to ask questions in greater detail at the end, feel free. But the framework that we use essentially account for all the first cost and future costs of a product, and get it all into present value terms, and so you get a total economic cost. On the environmental side, it's a little more complicated. Basically, you have to account for every single type of environmental flow that you might be dealing with, and then those can get associated with different types of environmental impacts. And in some cases, emissions can actually have impacts in multiple categories depending on what it is. And so what we do is actually aggregate those to 12 different environmental impacts, and then we've also developed an approach to get a weighted normalized average to get a single environmental performance score. And the reason for this is very few people, one, understand what these categories really mean and how important they might be to them. So we wanted to try to develop a way that makes it so you have a single value that you can compare. And so this is the current version of BEES. We shifted from an executable to an online version. You just go to the website and you can use it. It's free to use. Everything we do is free to the public. The initial version of BEES came out in 1997. It went through a number of different iterations, but when we shifted away from the executable to a web application because it's much easier to maintain, and you don't have the issues of the different types of operating systems and so forth. So you can see it has a little bit of an outdated look. But it's a very basic tool to use. There's a few inputs you have to put in. You select the type of product that you want to compare. In this case, I selected flooring. So you can grab out of, I think there's 40 or 45 different flooring products you can select. And then you can actually make the comparison, see some basic graphs and some data tables that you can use. So it's pretty simple to use, pretty straightforward. You can compare products side by side, and things have actually been quantified. It's not just simply is this certain, does this have a certification or not. You can actually look in terms of all the potential environmental impacts that it may have. So right now we're actually working on updating BEES because one, it's a little outdated. Two, we really wanted to try to target that sustainable acquisitions kind of area where they're trying to select different products that meet certain requirements, whether it's recycled content requirements or required certifications, while still allowing you to compare those products in terms of these metrics. And so what we've done is we're updating the interface to make it look more look and feel a little bit newer, but it has some additional functionality. We've actually incorporated in some filtering options. So then you can filter down to say you have to, maybe you're trying to select a flooring product that has 20% recycled content. So we're actually allowing you to do that within some of the filtering options. Or maybe you need a product that has a certain certification if that's required. So then you have a lot of the same similar underlying assumptions you have to make, such as discount rate. Also, we're incorporating in the social cost of carbon, as well as, or you can actually input your own value. So we give a lot of defaults, but you can customize it based on what's actually best for your situation. And something that we've also done is we've increased the flexibility in terms of the use phase. So this is important for some products in terms of, so for example, flooring, depending on how often you clean it and what method you use to clean it, could have a very big impact on what your environmental impacts are. So for carpet, if you're vacuuming it every week, that can really add up in terms of the electricity you consume to vacuum. So that's something that we wanted to include in as an option. And we'll have some default values, but people can put in what values are actually appropriate for them. And then it'd be very similar. We'll have a couple of summary tables, and we're also then going to incorporate some of the same types of graphs that we have in the other version. This is just a prototype at this point, so the numbers are pretty ugly at this point for how it's formatted. But so you kind of see what's coming. We should be releasing a version sometime in 2017 for that. So that's just looking at individual building products. Well, we wanted to take that same concept and actually apply it to whole buildings. And as you would expect, it might be a little bit more complicated. Instead of having a single product, looking at all the inputs, you actually have thousands of products going into a building. And so we had to really take a hybrid approach where you kind of take a baseline building and you use industry average data to look at the environmental impacts. And then the things that you're really concerned about, the things that change, increasing the energy efficiency through more insulation, better windows, more efficient HVAC equipment. Those are the things where we have very detailed data on that it's very expensive to estimate versus using the kind of the industry average data. So we had to find a good hybrid method to do that. If you have any questions on that, you can ask me at the end. I don't want to get into the details because it can get pretty complicated. So what we do is we combine cost data, the environmental flow data, and the energy simulation modeling and the results from that modeling to make the same types of calculations. So you're looking at the life cycle costing, you're looking at the life cycle impact assessment. So we have cost data for commercial buildings. We're primarily using RS means data. For the residential side, the database that we've been using, it's kind of a combination of some reports that were done. Faithful and Gould was the contractor, I believe, for PNNL when they developed some cost data for residential side. We've also actually had some cost estimation work done specifically related to the Net Zero Energy Residential Test Facility to price out the cost of all the different components of that building. So combining the characteristics from the energy model with the cost data, we're able to calculate the first cost for construction, as well as all the environmental flows associated with constructing the building. Then with the energy modeling, we actually know how much energy is being consumed, and based on location-specific energy costs, we can actually estimate the total cost for energy over the study period you're looking at, and the environmental flows associated with that. And then obviously you still have maintenance, repair, and replacement you have to deal with the building, and then any residual value at the end of the study period that you're looking at, and any flows associated with that maintenance, repair, and replacement. Summing up all the present value costs gives you your life cycle costing, and then aggregating up all the environmental flows gives you your life cycle assessment. And then those last two that I mentioned that we're starting to work with, we're going to include into the next version for one of our databases, is the thermal comfort and the indoor air quality. So we've actually got 4 different metrics you're going to be able to use to compare different types of levels of energy efficiency in different buildings. So we currently have 3 different databases that we've developed. A commercial buildings database that we're currently updating, a residential database that's really based on AACE requirements, and then the database based on the Net Zero Energy Residential Test Facility. That includes 240,000 different building design combinations for the Gaithersburg, Maryland site. So the first 2 are really based on code and standards requirements spread out across the country. It's kind of an inch deep but a mile wide. Where the 3rd database, looking at the Net Zero Energy House, since we have measured data, we could validate the model in terms of the energy modeling. Then we did a really deep dive of the performance there for one location. So that's more of an inch wide but a mile deep. And so we're working on kind of in both of those areas, because you really kind of want to see what combinations are optimal as opposed to just looking at what the combinations are required by the code or the standard. So for the BIRD software, we pre-process everything. We use prototype buildings that we develop, we simulate, we run the simulations, we use those results and run through the database code to generate results that then you can call on in real time. Problem is, it's a prototype. So, you know, the 3-story office building that we used, or, you know, the 2-story house that we use for the model isn't really applicable for every single building option. So what we wanted to do is allow somebody to do their own custom building design and do all the same types of calculations. And so what we've done is we've been working with the National Renewable Energy Lab with their Open Studio team. And Open Studio is essentially, it's an operating system that was developed around Energy Plus, and they've developed applications that can use Energy Plus, but it's much more user-friendly. So there's a GUI, there's an interface that you can use. And what they've done is they're actually able to pull out the building characteristics and the energy results from the Energy Plus simulation, send us the information we need to do our calculations, and it gets sent to a web server that our API basically have a calculation engine sitting there looking at that web server waiting for something to be sent in. And then once something hits, we grab the file, parse it, run the calculations, create an output file with basically looking at that, you know, those life cycle cost values, those different environmental impact category values. Goes back to the web server. Open Studio is waiting for that file, pulls it in, and then you can see the reports within their report section. So you never actually have to leave Open Studio. You don't see any of this. All you see is here clicking a button that says start, and then at the end you look at the report. And so all that's happening in relatively real time at this point, because the calculations for this are relatively straightforward and simple. So, you know, this is where I think the biggest potential impact is, because when it comes to architects, designers, every single, especially for commercial buildings, they're so unique, every single one of them, that you can't really apply the results from one to another. And so, and one other fact too is that this input file that's being sent in, it's just a simple text file. So as long as you send the information in the correct format, we don't really care whether it's coming from Open Studio or not. We can still generate that output file. So I've actually had a couple of discussions with people from Autodesk. So I think one possibility is for Revit, where they could actually do the same thing, send us the same information in the same format, and we can send them those results, and then they can pull those in. So I think this is where the potential biggest impact is. And this is where I've been wanting to go all along, but you have to take those incremental steps to make sure what you're doing makes sense and getting to that point. So this is where I'm actually really excited about what's going on with this. So we're at the point where we probably in the next 2 weeks, we should actually be able to correctly send the results through this process. So that's an overview of my project related to sustainable buildings. Moving on to the next project, community resilience. And just to give a clear definition of what we mean by community resilience, because that's another word that people don't necessarily know really what it means. what you're looking for is the ability for a community to anticipate, prepare for, and adapt to changing conditions and respond to and recover from disruptions. So one, you want to make it so it can handle changes more easily. And then if you have a change that you can't handle, you can actually recover from it more quickly. So that's really what it is that we're trying to do. And particularly for when it comes to decision making, similar to what I did with the metrics and tools for sustainable buildings, developing a framework and the metrics that you can use for analysis, and then tools that can assist you in making those decisions in terms of getting the best return on investment, biggest bang for your buck. And there's two ways that we're targeting this. One, the larger resilience effort actually created a planning guide. So it's not just looking at the economic decisions, it's looking at everything you have to consider for trying to make a community more resilient. But what we did is we created a supplement for that, which is the economic decision guide, which walks you through how you go about looking at the different alternatives and making the selections. And I'll talk more about that in a second. And then also a little bit more focused research with regards to looking at the different aspects of resilience and trying to quantify and develop methods for some of that. So for the economic decision guide, you can see that it's the NIST special publication 1197. And really what it's doing is trying to create a standard methodology. So that way you can use that over and over again consistently. And it's really to try to help make efficient choices, prioritize your options with regards to what's going to give you the best overall net benefits. So it's benefit cost analysis, looking at across different alternatives relative to some baseline. And now that they've developed the guide, they're actually moving forward with regards to standards. They've actually got approval to start the process for getting some ASTM standards developed for resiliency. And then for the tools, they actually have a version. It's not even really an alpha version at this point. And so for the economic decision guide software, is something that they're currently working on. We have something that functions, but it's really, really basic. It was actually developed by an intern this last summer. However, we are starting to look at trying to expand its capabilities and incorporate things such as sensitivity, uncertainty, that type of thing. So it's pretty basic where you start your analysis, or you can actually pull in an existing file, so you don't have to start from scratch every time. And you input, costs, different externalities and benefits, particularly for fatalities averted. If you're trying to decrease the impacts of a natural disaster, you'd expect that you'd be decreasing fatalities and injuries. And then there's other things that you might not be able to quantify in terms of dollar amounts, in terms of the externalities. And just an example of, if you create a new item here, you can actually put a full description in of what it is that you're pricing out, how much it is, and which scenarios it might apply to. And then once you've inputted all the benefits and costs you want to include, it will actually generate the overall life cycle costs and a breakdown across all the different categories. So there's two alternatives relative to the base case, looking at what your return on investment is and so forth. So I said it's pretty basic at this moment, but it's straightforward to use. We'll add in functionality over time. I believe they're going to come out with a beta version that they're going to use and pilot it at a number of different communities across the country. I'm not sure I don't know if they've been finalized yet and who's going to use it yet, but I think it's going to be a very useful tool that will really supplement the community resilience effort. So along with the decision guide and the software tool, doing a little bit more kind of core research here, looking at business continuity disruptions, really looking to see what actually leads to a business being more resilient. So, it may be the case that there's certain characteristics of different types of businesses, or maybe one particular business, for whatever reason, took some action that actually led to less of an impact from the disaster. And the other aspect is the difference between interruption costs and the actual physical losses. So just because your building didn't get destroyed doesn't mean that you didn't have disruptions in your business and you lose business. So, you know, if your building's totally fine but you lose power, then you might not be able to do anything for a month. And those are interruption costs that aren't necessarily impacted from your actual physical building. Another thing that they're working on is trying to quantify what's referred to as the resilience dividend. Another way of thinking of it is co-benefits. So they're actually benefits that you get that aren't really directly related to reducing the risk of the disaster. So just an example, if you build a new bridge that is going to replace an old bridge that wouldn't handle an earthquake, so you're trying to reduce the risk of that bridge falling apart. If the bridge is wider, maybe it's better located for traffic, you can actually get some immediate benefits along with the benefits to the economy of building the bridge. So you have all that money flowing in for that. So there's a lot of benefits that could be realized year after year and in the short term that can actually offset the cost of the project itself. And then the resilience benefits are really just kind of icing on the cake. So I kind of compare it to with regards to energy efficiency. If you can show energy efficiency is cost effective, but all the environmental benefits you get is just gravy. So it's the same type of concept here. And so they're looking at developing methodology to try to actually quantify these values. And then also in terms of application, what they're doing is they're looking at what's called computable general equilibrium modeling. Keep it high level here, but when it comes to general equilibrium, what you do is you look at kind of a regional economy, you look at the kind of the key components of that economy and how they interact with each other. And so, you have households, you have companies, you have the government, and you have the overall regional economy, and they all impact each other. Most modeling approaches, they just look at it in terms of this how all households impact all firms in this manner, and they don't really take into account some of the complexities involved with an actual community. So what we're working with in terms of Colorado State and some others, there's the Community Resilience Center of Excellence that's been put together. They've actually started working with what's referred to as spatial CGE modeling. So it not only takes into account how the different pieces of the economy interact, but how they interact with regards to its actual spatial location. So this is just an oversimplification. It's actually called Centerville. It's just a town that they created to show the feasibility of the software. But something to think about through into greater detail. So say you have a flood. So the floodplain's here. Actually, then the water comes out and actually damages this mobile home park. And then this is some middle income housing. So if that area floods, it doesn't actually directly impact the high income homes, but it could have an impact on those high income people in a number of different ways. So if these people have to leave their home and they leave the town, they go someplace else until they can fix their homes, then they can't go to work anymore. So maybe they're not at the retail businesses that are here. Maybe they're not at the Walmart and Home Depot. By the way, I'm not advertising for those two companies, just to be clear. But so they're not there. So then maybe businesses can't actually stay open because they don't have the workers, and so then it impacts throughout the economy in that manner. Or alternatively, if there's a wildfire here in the hills and it takes out all the high income locations, you have the same thing. You have that population moving away either temporarily or even possibly permanently. So you have the issues with New Orleans where people moved and then they never came back. If they're no longer here, maybe the businesses can't stay in business anymore. People they no longer have the demand for their goods, so then they can't hire. They can't keep everyone on. So then those people no longer have jobs. So there's all these different interactions that you have to think about. Then there's other aspects too of with power. Maybe power only goes out in certain areas and so forth. But it's just a couple of examples of the complexities that they're starting to delve into in a greater detail in these general equilibrium models. As I know just enough to be dangerous in this area, but if you're interested in what's going on here, then I can get you in touch with the right person. So that's the community resilience effort. Another project that we're working, actually it's multiple projects related to fire research. Fires, obviously a major issue. You have, for 2015, you had over 1 million fires that were reported in the U.S. Several thousand people died. There's 13,000 injuries. In terms of property damage, it's over $10 billion. But there's a lot more economic burden than just these values, because we spend way more money just in fire prevention than we actually do in the resulting damages from fires that actually occur. So one way to think of this is, instead of necessarily, well, there's multiple ways to reduce the economic burden of fire. One, you continue to reduce the actual fires that occur and the damages from those fires, but also reduce what it costs to try to prevent the fires. So if you can target, with firefighting, well, maybe which one would be a good one to explain? So maybe for this maintenance of fire protection systems, maybe you find a more efficient way to identify faults or issues. You can actually make it cheaper to maintain those, and then you can actually save money in that way, as opposed to targeting the actual fires themselves. So there's different ways to try to improve your return on investment in terms of trying to reduce the economic burdens of fire. And there's a number of issues related to fire research. One is accuracy, dealing with the costs as well as the loss estimates. It can be pretty difficult to actually quantify injuries and the value of statistical life. There's a lot of controversy around that, and a lot of the benefits that you get in terms of avoided losses, it doesn't actually occur, so it's not observed. So it's difficult to know exactly what the counterfactual would have been if you hadn't taken the action to reduce fires. So that can be difficult. Then you also have a lot of uncertainties as things change over time. You've got the aging population, where what's actually found is that older individuals, it's more difficult for them to get out and away from fires. So as you have a larger population, you may want to target different key methods to reduce those impacts. You have movement, so you have population growth in different areas. You have people moving from one place to another. You have to take that into account as you're planning. Changing in climate, that is always going to be an issue. I mean, you have all the drought that's been going on in California. There's been a lot of issues with fire there. And then also emergent hazards. Basically what I mean by that is building into the wildland. So the wildland urban interface. So if you build a community that's right up next to a forest, you're creating a situation where a wildfire could then damage a community. And another area that needs work is the fact that models at this point don't necessarily do a really good job of associating the intervention taken with the actual results. So being able to actually associate an action with the outcome can be very important, because then once you know that, then you can start to figure out which ones actually give you the best return on your investment. So a few examples in kind of the key research topic areas. With regards to prevention, one of the key areas that NIST has been involved with is the fire-safe cigarettes. Basically developed a cigarette that puts itself out. So And you can see the difference in burn rates there for the three different ones. And so what this does is if somebody falls asleep with a cigarette in their hand and it drops, it's much less likely to start a fire. Same thing if you throw the cigarette butt out of a car window, it's much less likely to actually start a wildfire. So that's one area that, and what some of the research that we've done is really looking at what the economic benefits are from those fire safe cigarettes, and from the adoption of states requiring that's what's sold in that state. Then you also have the wildland firefighting, looking at suppression. So once a fire is occurring, how do you keep it from being bigger than what it needs to be? So there's a number of different methods that you can use, and what we've looked at is, well, what's the relative cost of doing each of those actions? Are there other ways of designing the community that maybe possibly lead to less risk involved for minimal cost? And then with regards to mitigation, looking specifically in residential homes, I think most commercial buildings nowadays have sprinkler systems, but in a lot of states it's not required in new residential buildings. So one thing that my colleague did is develop this tool, as you can see, kind of similar type of approach, something that's pretty straightforward, simple. A few inputs you have to put in, give you default values in case you don't know what values to use, but gives you the functionality to put in information if you have more information and more accurate, or that's more appropriate for your situation. And then you can do some sensitivity analysis to see whether or not it's cost effective to put sprinklers into a home or a community. And then also hazard identification. Just for the map, what this is looking at is the wildland urban interface. So this is where communities are actually in kind of butting against wildland areas. But you can also see it's color coded. So just because there's a woolly area doesn't necessarily mean it's really at much risk with regards to fires, because the climate really plays an important factor in there. Because if it's not, if it's really wet, if you have a bunch of snowfall, you're not going to have a fire. So you can see in the Northeast here, really green. It really means that even though there's a lot of wildland urban interface, it just means that there's not really much risk in terms of potential fires. But then you can see in the Southeast, as you've got more and more development in that area. You can see in California, there's some pretty significant spots of red there as a result of and particularly in California, this map would probably be redder if it was updated with the drought and everything. But so this is identifying where the issues are. So that's some of the work that we do. Similarly, with arson, you can actually identify hotspots, maybe particular environments that are looked for by arsonists to actually set fires. So there's certain characteristics of vacant buildings and so forth that they may target certain areas of a city, and so if you know the likely areas, then you can target those areas for more patrol or eliminating those conditions that actually lead to more arson. That's something that they're doing work on. And then also vulnerable populations. I just reviewed a paper by a colleague basically showing that the demographics of the people that die in fires is very different than the demographics of the people that are injured in fires. Basically, vulnerable populations in regards to older individuals as well as very young kids, they're less likely to be able to get away from a fire. So they have actually, they're the ones that are at most risk of actually dying in a fire, where other populations are much more likely to be injured, but not likely to actually die. So, that's just a few examples of the type of work that they're doing that I'm aware of. Then also there's data quality that I mentioned about underreporting or missing data. So, in some cases, a lot of this data is voluntarily reported. You have, missing data for entire counties. You have missing data within certain reports of different fires. So you have to find a way to adjust for those issues. And so they're looking at methodology, heavy duty statistics for imputations and so forth to populate that missing data to lead to some better analysis. So moving on to manufacturing. So manufacturing has kind of been a big topic area of late. Concerns of the decrease in manufacturing in the U.S. and stats kind of show that where really the U.S. is, in terms of growth rate, is pretty low relative to most of the developed countries in the world, and we're actually still below pre-recession levels in terms of value added, and incredibly lower for employment. And so, and a lot of this employment aspect actually is related to automation. So there's been more automation adopted, therefore fewer people that are needed per output. But in the same time, you have the global manufacturing has actually been going up pretty significantly. So obviously manufacturing's been an important area to look at. And really what we're trying to do is increase the U.S. industrial competitiveness through improving efficiency through manufacturing. And there's really two ways that we look at this. One is looking at the supply chain, trying to improve efficiency and improve sustainability, resource use and so forth. And then also new technology adoption and diffusion. So for the supply chain, really what we do is so this is a plot of all the inputs and intermediate goods that go to produce a motor vehicle steering unit. So this is one of the simpler examples that he could give me. Basically everything in here is a different industry that's producing something that goes into making that motor vehicle steering unit. All the way from, here you got oil and gas extraction for the energy that ends up getting used to produce things. You have inputs, so like looks like mining, so you've got gold, silver, and other metals, all the way through the intermediate goods, and all the way until you actually make the steering unit. And so throughout this process, we're trying to identify where the value added is, where the costs are associated with that product, the environmental impacts that are associated with it as well, whether it's resource use or the other impacts that we look at, and then also the amount of time it takes to go from step to step. So if there's one particular piece of the product that's really taking a long time, that could be a target to try to improve efficiency. And then also just the overall resource consumption by spot. And then once you've really identified these areas, then you can actually take action on those. So you can target efficiency in terms of the operations of producing that product, trying to improve efficiencies throughout the supply chain, and finding those hot spots or bottlenecks where you can actually have the greatest impact. So if you can, say one particular component in here takes up 50% of the time of the entire process of producing the product, then you can target that and get really significant time savings. And then when it comes to technology, looking at adoption and diffusion, really looking at what goes into the decision-making of adopting technology, developing methods to analyze whether or not you should adopt a technology, finding metrics that can be used to make those comparisons, and then identifying what barriers and what costs there are to adopting new technology. And because then once you've identified those, then you might be able to identify where you can get the greatest return on your investment of trying to reduce those barriers and those costs. Because if you reduce the barriers, you should increase technology adoption throughout the industry. And so that's where it comes down to diffusion of innovations. Really you're trying to increase the rate that new technology is adopted by the industry. And one example that we've looked at, we've really focused on assembly-centric manufacturing, cars and so forth. But one particular area of interest is additive manufacturing. So anybody who's not familiar with additive manufacturing, the people that do the research in this area won't like it, but it's essentially 3D printing. So instead of taking a lump of metal and then trimming it down to whatever you need it to be. You're actually taking the individual particles essentially and then building it up layer by layer. So you're adding to it instead of subtracting from it. So additive manufacturing is an area that is a very high-tech area. The U.S. I think is the largest user of the 3D printers. I think Germany actually produces them, a lot of them. But it's an area that can be ripe for potential growth because you can do very complex products. You can do products that have multiple types of materials in them. So if you needed something very specific that's very complex, it may be optimal to do it that way as opposed to trying to make the different pieces of the product separately and then putting them together. Just an example of the work. This is pretty early on into the project. It's only a few years old, but the NIST report, cost and cost effectiveness of additive manufacturing, in 2016 was downloaded over 17,000 times. Just for reference to NIST as a whole, other than really the information security research that's done, this was the largest downloaded document. So we just found that out just a couple weeks ago. So I wanted to give Doug Thomas and Stanley Gilbert a shout out for that, because that's quite impressive. I could only wish I had something that was downloaded 17,000 times. So, but so I think it's definitely an area of great interest, especially moving forward in the manufacturing sector if we're going to try to revive some of what we lost, because you know, likely what's going to have to happen, we're going to have to create essentially new industries as opposed to trying to get the old industries back. Just labor's too cheap elsewhere. So moving on to the final project. This is actually the first year we've had this project. It's really looking at the economics of the smart grid. And what we're trying to do is identify the economic issues related to actually modeling a smart grid. And really it comes down to looking at the current versus the future electricity structure. At this point, most of the modeling approaches take the approach that's always been used, but we think that we need to take a broader scope of this and really figure out if there's a different way of modeling it that can account for a lot of the complexities that are going on and the changes that are occurring. And so these are just some of the issues that have really popped up. When you have issues with a lot of interoperability with different products and services that are coming out. I mean, you have, you know, their hope is for being a disruptor in the market. You've got Tesla in combination with purchasing Solar City, trying to kind of create this whole produce all your electricity at home type of situation. And so that's just an example of you know, new products that are coming out. You know, weather fluctuations and changes that are occurring over time that can lead to pretty significant impacts, and especially in combination with renewable deployment. You know, all the solar PV going up on people's roofs, but also wind, being large wind turbines in West Texas and in the center of the U.S. There's actually, I know there's at least one night when electricity had a negative price in West Texas because they were producing too much. There wasn't enough demand. They needed to get it out of the system or it was going to cause issues. So with that rapid deployment that occurred there, and I'm from Nebraska, and actually every time I go back, I see more wind turbines popping up. So it's not just the solar PV that's going up, which is going up quite rapidly right now as well. But those are things that need to be considered. And then also there's the demand response. More of the utilities are going at trying to shed peak loads as opposed to just continuing to buy on the wholesale market and sell you that electricity. So for example, I mean, this, one of the simplest examples is going to be, I actually allow Pepco to control how often my AC unit cycles on. And then for that ability, they actually pay me money during the summer months just for that right. So I get a little bit off my bill. They're able to drop their peak loads when electricity is the most expensive for them, and it works out for both sides. Demand response can be much more complex. I mean, you actually have companies that are coming in and promising to shed loads when demanded by the utility at a much larger rate as well. And then there's what the Smart Grid Program Office is really delving into is what's referred to as transactive energy markets. What it's really doing is it's taking a very different view of the electricity market. So the old view is the generator generates the electricity, it gets distributed, transmitted out, goes to the consumer, consumer consumes it, and pays for that electricity. But really what's starting to happen is you're getting a lot more potential for electricity to flow either direction. So the solar PV panels on your house is a perfect example of that, where during the middle of the day, very very sunny day, but it's not overly warm out, you produce way more electricity than you're consuming. That gets pushed out onto the grid. The grid wasn't really designed to handle that, so they're really having to think through how they're going to restructure the transmission lines and how that electricity can actually flow both directions. And you've got with the customer, all these other things that could be going on as well. So with regards to somebody at their house, not only do you have the potential for the PV system, you've got smart appliances that are coming out. You have the ability to automate operation of certain things. You've got your thermostat that can start to adjust based on the price of electricity and so forth. And then, with industry, they've got even more complicated aspects because they can actually shut down entire operations to try to shed loads and so forth. So it gets very complicated very quickly, especially when you start transitioning, moving electricity both directions. So we're really early on in the stages of that, trying to identify the different issues that need to be addressed. And we're doing that in line with when they're trying to develop models to do this. So that's the kind of the key projects that we're working on. A few other things that we're doing. I mentioned the DOE project that I'm involved with the building lifecycle cost software. So that's something that's used for all the energy savings performance contracts and so forth that they do. Then also we're currently having some talks with NIST's Manufacturing Extension Partnership Program that has sites throughout the U.S. trying to help manufacturers improve their efficiency and stay competitive. So we've had some discussions with them about trying to figure out what they're doing, what works and what doesn't, because right now a lot of what they do is kind of one-off actions based on who's interested. So we might be able to do some kind of policy or action analysis for that. And we're also looking at potentially doing some work related to Homeland Security projects that NIST is funding through the Special Programs Office. But, at that, I can open it up for questions.
At the beginning, when you were talking about building costs, life cycle costs, there was a module on maintenance.
Maintenance, repair, and replacement.
So, what's is that? Do you have a database based on something?
Yeah, so and we use a range of sources for the commercial side. Most of RS Means and Whitestone are been the two that we've primarily been using. And in some cases, if you can't really find a good replacement cost, then we can use the installed cost. The initial installed cost is the same value.
Okay.
Of course, once you get to 30 years out, so you probably get like maybe one replacement in most cases. Once you get out there, the discounting of those present value ends up not making much of an impact on the results. Especially on the residential side, that's what we're finding is the 30 versus 40-year study period analysis is almost identical.
Okay, thanks.
Yeah.
I know you have is it a building life cycle program and it's on your website that people can download and use? Or?
It's a building life cycle costing is actually on the DOE FEMP website. If you just search building life cycle cost, FEMP, it'll pop up. So that's a software we developed. We've been doing work with them for like 30 years. The software was last developed in 2006. and we've essentially just been updating the underlying data within that tool. But that's all customizable. If that's not the energy price escalations that you want to use, you can change those and everything. But the framework's there to do that type of analysis. And so it's largely used for energy efficiency and water conservation projects that are funded for government facilities and that type of thing. So it's actually, life cycle costing is required for energy efficiency projects for the federal government, and they encourage them to use the software. But so that's the software we want to actually shift to a web interface as well to try to alleviate the issues related to the executable. And I've actually had some conversations with somebody from Autodesk about they're doing some work for the Air Force to try to automate the process of doing the VLCC calculations. So if the new version, we may actually do something similar to what we've done with Open Studio, where you never actually have to leave their tool and will automatically do the same calculations and kick it back to you. So it decreases that manual step that would be required to do that. Because at this point, Autodesk actually created a way to create the input file to go into VLCC, but then you have to manually open it, run the calculations, and then send it back. So I think there's potential for automation and integration in a number of these areas that just we haven't pursued yet.
What sort of a discount factor you're using for like costing on the model that's up there? Is it a standard amount or do you?
So for the discounting, our starting point's 3% because that's the discount rate for energy efficiency projects for the federal government. But what we've started to do now is to actually include other discount rates. For the Net Zero Energy House, we did 3% first, but then we actually did 8% as well, which is kind of close to the real return on investment for the stock market. So depending on what your risk aversion is with regards to that, you can use that. We actually intend to do additional ones as well to give the ability to choose what's most appropriate for you. We're getting to the point now where it's an issue of how much data we have to manage. So the question is, how many options do we give for each? What's needed to get the reasonable result versus having too many options and not adding much benefit to the tool. Yeah.
Do you do much with the Green Building Council? I would imagine they use data that you generate, and we're always asked in our line, how much would it add to the project cost if you're doing various LEED level buildings? And does it add 2%, 3% on up?
Right, and that's an area that we've really focused on, just the energy efficiency piece at this point. But that's an area I want to delve into with some of those with regards to kind of the additional points that you can get for other actions that don't really necessarily have a real economic effect or energy effect. I've had some interactions with USGBC on the BEES tool because they have a material selection points that you can get. And you're supposed to select products that have what's you're familiar with environmental product declarations or not. So what we're doing is we're consistent with that same methodology because the underlying approach for the life cycle assessment analysis that gives you the EPD is called product category rule. And so we're using that same method to develop our results in the new version of BEES. So the hope would be then you can compare products and actually know that they're comparable, because the environmental product declarations aren't really comparable because the underlying software that you use, the underlying data you use, and all the assumptions that go into that life cycle assessment, unless those are all exactly the same, you can't really compare the numbers. And that's where we're trying to be consistent of having the same exact approach to doing all those life cycle assessments. So we've interacted with them some. It's a little slow going at this point. I've also interacted with some of the government agencies to see if this would be something they find of interest with regards to green acquisitions to select products. So, but yeah, so the hope would be that we could delve into some of the non-energy related green features associated with LEED or some of the other green certification programs and take that into consideration. So We think the net zero energy residential test facility would be a good option because all those products, like they're all low VOC products and so forth. So what we could do is we could look at the differences in prices of meeting those low VOC requirements, and then use kind of a software that NIST developed called Contam that actually is really kind of the best software to try to look at indoor air quality. And then being able to test to see how the indoor air quality changes if you were to, instead of having the low VOC or no VOC paint, having something that's kind of a typical product and see how it changes. And then you can also compare what the costs are. So you can look across all the different sustainability metrics to see how it impacts the end result. So I've thought about these things. We haven't gotten to the point where we can start to, we have the time to work on those areas. And so we felt that the biggest kind of return on what we're doing is to really focus on energy efficiency and then broaden out from there.
Well, then I just want to say thank you to Josh for coming and doing this. And just one couple more announcements for the AACE folks. Please make sure you register for the holiday party we have coming up on the 12th. It's going to be in DC at Bobby Van's Steakhouse. Anyone from SAVE or ASPA are more than welcome. It's free of charge for everyone. So we want to, have a good opportunity to network and, just enjoy the year and celebrate the year. So again, one more round of applause for Josh. Thank you.
If you think of anything else, or you mentioned to somebody and they're curious about anything that I talked about, you can contact me. I'll get you in touch with the right person. If it's not me, if you want a card, I've got a stack. So that way you don't have to write anything down.
Thank you. And we'll send out his presentation. If you want.
No, it's fine. You can have the presentation.
Great. All right. Thanks. And thanks everyone for coming out.
Thank you.